Okay, boys and girls, this is day 5, and we're going to do bell work together. So I've given you 9 functions to graph, and they're a combination of linear, quadratic, and absolute value. So you have to use all of your skills to graph this. So why don't you try this on your own, and then I'll come back and I'll show you how to do them, or I'll give you the answers. All right, welcome back. So I'm just going to kind of go through the type of function it is, and then we're going to sketch it together. So in this first one, this is a linear function. I know it's linear because I don't have a square and I don't have an absolute value. So this is a linear function. So if it's linear, I use the slope and the y-intercept. The y-intercept is -3. The slope is 1 over 2, so I go up 1 and over 2, up 1 over 2. And I could probably use a ruler if I were you to sketch that line. Okay. The second one is an absolute value function, so it's going to look like a V. So this is absolute value. And I know that because it has absolute value. So if it's absolute value, I'm going to need a vertex and a slope. So to find the vertex, I go to x is 3 and up 1. My slope is 1, so then I'm going to go up 1 over 1. These are little lines. And then I can graph it from there. All right, so if it's quadratic, we haven't talked about how to find the solutions. You can't do that by graphing it, but I'm just going to sketch it like we did before. So my vertex is x is 2, positive 2, and y is 3. 1, 2, 3. So this is going to be quadratic. It's going to be U-shape, and my vertex is 2, 3. So I go to 2, 3. It's going to be like normal, so I'm just going to kind of sketch a normal graph there because it doesn't have, it's not a vertical stretch or anything. All right, in the next one, this is absolute value because we see the absolute value symbol, so it's going to look like a V. Our vertex is -1, -5, and our slope is 2. So we go to x is -1, y is 5. I'm sorry, y is -5. These little lines are hard to draw on. Sorry about that. And our slope is 2, so we're going to go up 2. Okie dokie. Let me make this bigger because, old age people. All right, so let me start this again. I'm going to go to x is -1, y is -5. My slope is 2, so I go up 2 and over 1, up 2 over 1. So it's a little skinnier. I'm just going to sketch it from there. Okay, this one is quadratic. How do I know it's quadratic? Because of being raised to the square like that, so I know it's quadratic. I know my vertex is at 2, -1, and I know that it is reflected about the x-axis. So I want to go to x is 2. This is x is 2, and y is -1. It's reflected about the x-axis, sorry. So it's going to go down like this, and it's again has a is 1, so it's going to be about the normal size. Number 6, this is linear. It's a linear function. It has a y-intercept of 5. It has a slope of -4. So we have a slope of -4. We have a y-intercept of 5. So we're going to go down 4 and over 5. And it's negative, so that's why I'm going down. And I have no idea what I just said. I'm going to go down 4 and over 1. So that's going to look like that. Just remember, slopes can be written as anything over 1. So that's going to look like that. Sorry about that. I have no idea why I just said that. And then this one is quadratic. It has a vertex of -4, 1. So we're going to go to -4 and 1. It's a little bit skinnier because it's a vertical stretch. So we're going to just make it a little bit skinnier than normal. Again, this is linear. It has a slope of 3/5 and a y-intercept of -8. So we go down to -8, and then we go up 3, 1, 2, 4, 6, 8. So this would be -8, and we're going to go up 3, 1, 2, 3, and over 5, 1, 2, 3, 4, 5. And we got that. You can also sketch these on your calculator to see what they look like. Again, this is absolute value. We have a vertex of -1, 0, and a slope of 3. So we start at x equals -1, y is 0, and a slope of 3. So that means I go up 3, 1, 2, 3, and over 1. It looks like that. Okay. Alrighty. So that's the answer for the bell work. So now today what we're going to do is we're graphing piecewise functions. Okay? So our objective today is to graph piecewise functions with non-linear pieces. So what we've done before is when we've graphed a piecewise function, they've all been linear. But now we're going to try doing linear and nonlinear functions and see what it would look like. Alrighty? So, like we said before, when we're doing a piecewise function, we have to start with the endpoints. So our endpoints here, our endpoint is 0, 0. This has two pieces. It has a quadratic piece and a linear piece. So it has a quadratic and a linear. So we're going to have a parabola and a line. So our endpoint is 0. So when x is less than 0, that would be, I'm going to call this A and this B. So when x is less than 0, and I put that into A, I get 0. 0. X is 0, y is 0. The type of graph is x squared, so it's quadratic, so it has a U shape, and x squared will have a vertex at 0, 0. So I know my graph is going to start at 0, 0, because that's my endpoint. And because it's a parabola, y equals x squared, I know from 0 to infinity, it's going to look like a parabola. Now for the second part of this, let me get a different color. The second part, when I put 0 into this function, I get 0 plus 2, so I get 0, x is 0, y is 2. The type of graph is linear, so its shape is going to be a line. Its slope is 1, and its y-intercept is 2. The slope is 1, y-intercept is 2. My starting point is x is 0, y is 2, so it's starting on its y-intercept. Convenient. And then I know it has a slope of 1, so then I can just go up 1 over 1. And I finish my graph. Now, I need to talk about endpoints. So on this first graph, we have x is less than 0, meaning that it is not defined there. So this graph would have an open circle. So this should have an open circle. It's greater than or equal to 0 here, so this one would have a closed circle. And that's my little graph. Okay, let's do another example. I have two functions. My first function is quadratic. The second one is absolute value. So we're going to start with the endpoints. So when x is greater than 0, if I put 0 here, I get 0 minus 1 squared, which is 1. So that endpoint would be x is 0, y is 1. The type of graph is quadratic, so that means it's going to be a parabola. The shape is U-shape, or parabola, and its vertex, if I look at this, the vertex is at 1, 0. Okay? So let's start by graphing that piece. So I'm only graphing, this starts at 0. It has a vertex of 1, 0, so it has a vertex over here, so I'm not really going to get to my vertex. So I start at 1, is my first point. And I know my graph would look like, if I were to graph it completely, it would look like this. Okay, because this is my vertex, so it would look like this. But my graph ends at 0. So I'm going to erase all of this because my graph ends at 0. And it has an open circle, so it's going to have an open circle at 0. X equals 0. Okay? My endpoint for the second one is still 0. So if I put 0 into that, I'll get a different color. So I have 0 plus 2, the absolute value of that, which is 2. So my endpoint would be 0, 2. The type of grab is absolute value. The shape is a V, and its vertex is at -2, 0. So we're not going to see its vertex either. So if I were to graph this, I'd start at x equals 0 and 2. My vertex would be at -2, 0. So the graph would look like this. We'd go up 2 and over 1. Our graph would look like that. Up 2 and over 1. So we'd have a point here. Up 2, over 1. We'd have a point here. So look like that. Okay? But remember, my graph is only defined starts being defined at 0. So everything to the left of 0 is going to be eliminated. None of this is there. And my graph would actually start at 0, 2. And because it's defined at 0, 2, it would be a closed circle. So it looked like that. So you can't really tell its absolute value because of it's a V shape, and the V part doesn't start to the other side, but that's still the same thing.